Okay, here we go. The last section, numbers 21 through 30. Same concepts as before. These problems get a little bit more messy, but concepts are still the same. So, and just look at 21 at the moment. It says perform the indicated operation. Assume all variables are positive. This part really doesn't even mean anything, but notice these are the same. So if those are the same, kind of like before, those are not going to change. You can only add and subtract roots if root size is the same, okay, and the stuff in the root, or the technical term is the radicand, okay, that's the inside stuff, okay, is also the same. So if you look, these are both square roots and they both have 2z. So what happens when we do that is we just worry about the outside numbers. So we have 11 square roots of 2z minus 5 square root of 2z. We're going to ignore these for a second, and 11 minus 5 is 6 square roots of 2z. You give it like 11 apples minus 5 apples, I get 6 apples, okay? They look messy, but they're really, really simple. We just can't overcomplicate them, okay? The next one, that was 21. This is number 22. It says use the properties of rational exponents to simplify. So all of our exponent rules tell us we can only do things if our bases are the same. So if you look at these, we have 2, 16, and 4, and you're like, what in the heck? Okay, so I'm not going to keep them as exponents. I'm going to change them to powers. So if you look, this is the cube root of 2 squared, right? Roots on bottom, powers on top, times the cube root of 16 squared over the cube root of 4 squared, okay? And so first thing I'm going to do is I'm going to simplify the numbers on the inside, because this is what Miss Buss will do. There's lots of ways you could go about it, but I would first go 2 squared is 4, 16 squared is, I don't know what 16 squared is, so I'm going to get my calculator and go 16 squared, 256, over the cube root of 4 squared is 16. And that's looking a little bit better, but we're going to keep going, okay? And I'm going to focus on the top. And the top, when I multiply the insides. So I get 256 times 4. 256 times 4, I get 1024 over the cube root of 16. Well, here's the cool thing, okay? I can now write this, because the root sizes are the same. I can write this as 1 root, and I can simplify the inside. So I'm going to go 1024 and divide that by 16. Well, not 166. 1024 divided by 16, and I get the cube root of 64. So nice, so much smaller. And I go, the cube root of 64. Well, let me see if I can break that down and see what I can pull out. So I go, 64 is 8 times 8, which is 2 times 4, which is 2 times 4. 4 is 2 times 2. I got 3 2s. Oh, and I got 3 2s there. So I get 2 times 2, which is 4. Killing it, killing it, killing it. Love it. Okay, that's 22. Moving on to 23. Use the properties of radicals to simplify the expression. Look, this looks just like the problem we just did. So I'm going to do it where I'm going to combine the top. So I have the cube root of 6 times 72 over the cube root of 2. Make sure you're really careful and it's a little 3, okay? So I'm going to find out what 6 times 72 is. 6 times 72 is 432 over the cube root of 2. And like before, I can write it as 1. And I know it's not going to give me a decimal because they're both even. And I get 432. I'm going to divide that by 2. When I get 216. So now I need to find out what the cube root of 216 is. Okay. And a couple things I can do. I can break it up by hand. Okay. Or I can use my calculator and see what I find, okay, if you use your calculator, even though it says not to, you would do 216 and you'd raise it to the 1/3. Okay, so I'm going to do that. 216, I'm going to raise it to the 1/3 because first power, third root, and I end up getting 6. Okay, so that's the answer. But if you don't want to use a calculator, which is totally okay, because if you've listened, this doesn't have that squiggly equal sign. So that means that you need to get a good complete answer. If I do 216, you might not know what multiplies except for you know that it's even. So you're going to say 2. So I'm going to go to my calculator and go 216 divided by 2. And I get 108. And you might not know that one either, but you do know it's even again, and you're going to get 2. You go 108 divided by 2, and you get 54. Okay, and if you don't know your times tables for 54, you know it's even again, and you can keep doing 2. Okay, if you did, you get 2 and 27, and then you're like, okay, 27 I know is 3 and 9, which is 3 and 3. And if you look at your groups of 3, you have a group of 2s and a group of 3s, where you get 2 times 3, which is 6. Okay, both ways work, both ways are correct. Just know what answer they're looking for. This way, if you get decimals, you're going to have to do it the other way. Okay, that's 23. 24, simplify the expression in simplest form. Okay, same exact idea. These are the same ideas. If you were to do 64 divided by 9 in your calculator to try and see if that simplifies, divided by 49, you get a decimal. So you know that's not going to happen. So we've got to separate them. Okay, and I'm going to try and simplify them before, so I'm going to break them up. And 64 is 64 is 8 times 8, which is 2 times 4, which is 2 times 4, which is 2 times 2, which is 2 times 2. So if you look on top, I have a group of 2 groups of 2's, so I end up getting 2 times 2. You okay with that? Okay, but on bottom, I have 7 times 7, and I only have one of those. Okay, so on top, so hold on, rewind. Okay, I only have 2 of those. I need another one. So what I'm going to end up doing is I'm going to have to multiply both the top and the bottom by the square root of 7. So when I do that, I get 1, 2, 3 of them, and they get to come out as just a 7. And then on top, I have 2 times 4, which is 4, square roots of 7, over the 7 on bottom. Okay? I know that's kind of a lot, but it's the idea of simplifying and then trying to make sure that there's no root on the bottom. Okay, 25. 25 is a lot like a problem that we did in the other video where we have adding on the bottom. So this time we have subtracting on the bottom, but the process is the same. We don't like roots on bottom, and we definitely don't like subtracting roots on bottom. So this is where we have to use the conjugate. Okay, and if you remember, the conjugate is just changing the sign in the middle. Okay, so we're going to multiply the top and the bottom by the conjugate of the bottom. So we're going to multiply by square root of 3 plus square root of 5. Okay, and when we do that, we do insides with insides, outsides with outsides. So on top, we're going to have the square root of 18, because 6 times 3 is 18, plus the square root of 30, because that's 6 times 5. And then on bottom, we're going to have the square root of 3 times 3 is 9. That's that first one. Then the plus the square root of 15 minus the square root of 15, because we have this negative root 5 times 3. And then minus the square root of 25. And so now I'm going to simplify everything I can. Okay. In the top, the square root of 18 is 9 times 2, which is 3 times 3. So that first one simplifies to 3 on the outside, 2 on the inside. Okay. And we're going to see if the square root of 30 simplifies. 3 times 10, 2, and 5. I don't have any matches, So I'm going to leave it as the square root of 30. Okay. Then on bottom, the square root of 9 is 3. Okay. Plus root 15 minus root 15. This is why we multiply by the conjugate, because these cancel. Okay. And then minus 25 is the square root of 25 is 5 times 5. So that's minus 5. So we keep simplifying. The top's going to stay the same. Oh, I forgot the root sign. And then the bottom is 3 minus 5 is negative 2. Okay. Killing it. It's a lot of work. So understand that Miss Bussel's going to know you're a big fat cheater if somehow you get the answer and there's 0 work on there. It's impossible. You can't do it. Okay. Number 26 says simplify the expression. Simplify the expression. We're adding roots. So the only way we can add roots there's 2 things. Root sides has to be the same and inside has to be the same. And you're looking at this, you go, oh my heck, the insides are not the same. Well, let's see if we can get them the same. Okay, the roots are the same. So I can't make 7. I'm not going to worry about 7, but I'm going to try and change this one. And so 224, we're going to try and make a tree out of that. So I know I'm going to go 224 is even. I know it's divisible by 2, but let's be risky and see if it's divisible by 4. Oh, it is. Okay, so we get 4 times 56, and 4 is 2 times 2. Okay, 56 is 8 times 7, and 8 is 2 times 4, and 4 is 2 times 2. Look, 1, 2, 3, 4, 5 2's. So that first one, 5 2's come out as a 2, and then all I have left is this 7 on the inside. So now I have 2 fifth roots of 7 plus 3 fifth roots of 7, and I get 5 fifth roots of 7. Okay, boom, worked awesome. Okay, simplify the expression. With this one, I can't do division because they're not the same base. M and N are different. So I'm going to separate this by going the fifth root of m to the 10th over the fifth root of n to the 5th. And I'm going to simplify the top by itself, simplify the bottom by itself. And if I have 10 m's, okay, you can write it like this. There's 5. There's a group of 5. There's another group of 5. So on top, I have nothing left over because 5 and 5 is 10. I have 2 groups of m, or m squared, right? And on bottom, I have 1 group of n, which is just n. M squared over n. Pretty simple. Okay, 28, same thing. We're going to simplify them individually. So I'm going to do the fifth root of 160 m to the 6th over the fifth root of n to the 7th. And so we might need to, I'm going to change colors so you can see this. 160, you're like, what the heck? I don't even know what multiplies that, but I do. I'm going to go 10 and 16. Okay, and 10 is 2 and 5, and 16 is 2 and 8, and 8 is 2 and 4, and 4 is 2 and 2. So I broke that down. If you notice, I have 5 2's. Okay, so my 2's are going to come out, but then I still have this 5 left on the inside. So I'm going to remember that. Okay, so I'm going to even write it. A 5 left on the inside. And then I have 6 m's. Okay, and I can take 5 of them out. And I have 1 left on the inside. So that's how the top simplifies. Okay, then the bottom, we have 7 n's. Okay, and I'm going to take 5 of them out. And on the inside, I have 1 n left. So the best answer is on top, I have 2m square root of 5m over n square roots of n. Okay. Perfect. 29 says use the properties of rational exponents to simplify. Okay, couple things that we need to notice. On top, we have the same base. So I'm going to focus on simplifying the top currently first. So if the bases are the same and I'm multiplying, I can add the exponents, okay, and then simplify from there. So I'm going to do that. I'm going to go 3/8 plus 7/8. And it gives me this decimal, but I'm going to do 5/4. Okay, so on top now I have 49 to the 5/4. Okay, and then on bottom now I have 7 to the 5/4. So I can't, because the bases are not the same, I can't just do anything. So now I need to change it into roots, because roots I can multiply and divide without things being the same. The only thing that's the same is the root side. So now I have, I'm going to come over here. Now I have 49 to the 5th power 4th root over 7. 7 to the 5th power 4th root. Okay, which then I can write as 1. 49 to the 5th over 7 to the 5th. Okay, and I can figure out what that is. I can use my calculator. I can go 49 to the 5th power divided by 7 to the 5th power. My goodness, and I get the 4th root of, that's ginormous, 16,807. That's got to simplify. Okay, that's got to simplify. So what I'm going to do there is I've got to figure out what that's divisible by. Let's see if it's divisible by 7. Yep, so it's 7 and 2401. Let's see if that's divisible by 7. Because I want 4s, right? I want a group of 4. Divide that by 7. Yep. 7 and 3. My goodness, what am I doing? 7 and 3, 43. Okay, that's divisible by 7. Oh, yep. 7 and 49, which is 7, 7. Look how many 7s I have. I have 1, 2, 3, 4. Oh, no. I can take out 1 7. But then I have 1 left on the inside. And if you look, none of your things are like that. Okay? But if you remember, this is 7 times the 4th root of 7, or 7 to the 1st power times 7 to the 1/4 power, which is 7 to the 1 plus 1/4, because I add my exponents. And if I grab this, I go 1 plus 1/4, and I make that a fraction. That's 7 to the 5/4, which is this one. Okay? You could also know that if you have a 7 on the outside, or look, we have 5 7s, 1, 2, 3, 4, 5. You could rewrite this as 7 to the 5th, which then is 7 to the 5th power 4th root. Okay? If you notice those things. If not, go through the whole entire process and use the rules. Okay. Use the properties of radicals to simplify the expression. This is the last problem, and this one's going to be awesome because it's not going to take much. Let's do that. So when we multiply, the only thing that has to be the same is the root size. So on top, we're going to have the cube root of 3 times 18, which is the cube root of 54. Okay, and on bottom, we have the 6th root of 2 times 2, which is the 6th root of 4. Okay, and so some of you are like, what the heck? Let's try to simplify. 54 is 9 times 6, which is 3 times 3, which is 3 times 2. So when I do this, this is 3 times the cube root of 2. Okay? Then on bottom, the 6th root of 4 of 2 and 2, that doesn't simplify. So now I have I can't simplify that, so I'm going to have to multiply it by something to simplify the bottom. So I have 2 of them and I need 6 of them. So I'm going to multiply this by the 6th root of, I need 4 more 2's. 2 times 2 times 2 times 2. You okay with that? So multiply this by the 6th root of 2 times 2 times 2 times 2. Okay, so we get 2 on bottom because I've used all of those. But now I need to simplify my top. So now I have 3 cube roots of 2 times the 6th root of 1, 2, 3, 4, 16, right? Yep, all over 2. Okay, and the only way that we could do anything with that is if the roots were the same and the insides were the same. We could try to do something, but since the root sizes aren't the same, we can't do it. So, man, that's okay. We'll be all right. It's a rough one. That's a yucky answer. You probably won't have one on the test like that, so I wouldn't stress too much. But let me know if you have questions and be ready to ask them.